My name is Robert Wood with Lightning AI, and today we are going to talk about jobs. The current state of the market is typically if you want to run your machine learning training jobs or experiments on high performance compute, you typically are developing locally, and then you have to either learn Kubernetes or potentially send your code to a DevOps engineer who knows Kubernetes in order to run that on a high performance compute infrastructure. At Lightning, we want to empower researchers and developers alike to be able to run their code on high performance compute without having to interface with a DevOps engineer. How are we going to do that? Well, the first way we can do that is through our jobs plugin in the UI. What this allows you to do is, without knowing any Kubernetes or having to orchestrate this yourself, you can just write your training code. So I have a simple recommendation engine training loop right here. And what I can do is just go into the UI. I can go to our batch jobs plugin. I can click new job. All I have to do is target that training script. And then from there, I pick the type of machine I want to run on. So let's just do an L4. And then from there, I can confirm and run it. And then now, instead of having to package everything up and send it to a DevOps engineer or learn Kubernetes and be able to orchestrate this on a cluster, I have just used the UI to do exactly that. And now I have all of the machine metrics when they pop up. I have the logs for the machine, and I have all of the details about who ran the job, when it ran, what type of machine it was on, how much it cost, how much memory, as well as the start and stop time. Now, the second level of jobs is typically, you can run one job pretty easily, but how do you orchestrate many jobs in parallel? And why would you do this in the first place? Well, when people are doing things like hyperparameter sweeps to find the right mix of hyperparameters to train their model the fastest and the best, they typically want to do a lot of experiments in parallel, but that's an even more complex orchestration task. So the way that we make that easy with Lightning is through the SDK. So I have my sweep launcher.py here, which takes that same script, that train movie lens.py, and then it takes all of the hyperparameters I want to test and loops through them. So this will create about 9 jobs because it's looping through 9 different permutations of hyperparameters. All I have to do is pick which machine I want to run on, which in this case is a T4. And then I can loop through and create a job that incorporates each of the permutations of hyperparameters that I want with just one click. So if I just do Python sweep launcher.py, what you'll end up seeing is many different jobs spin up at once. So we're seeing all these jobs successfully launched. And then if you notice on the right-hand side of the screen, the number of jobs has ticked up to 10. Similarly to the single job that we ran through the UI, we now have all the details about what's running, when it was ran, and in this case, the different hyperparameters associated with this experiment. And then we can add observability on top of all of those as well in order to see which model trained the best. And then the last mode in which you can send jobs is you don't even need to use a script or a set of scripts to run this. If you have Docker containers that are stored within Lightning or outside of Lightning, you have the freedom to use those to run jobs via Lightning as well. We're still taking away all of the need to orchestrate all of this infrastructure yourself. But if you have a container that's sitting elsewhere, feel free to just point Lightning to it. Make sure you have all of your API keys and IDs within the job that you're submitting. And then from right here, I have this container. This could be sitting anywhere on ECR, Docker Hub, or within our container registry. And then all you need to do is, once again, I'll go Python container job.py, which will run this. So what we should see is a my Docker job, and which will run this on an L40S machine. So if I click that, it should once again say my job was successfully launched, which it was. And now, since this job is not associated with the studio, I'll come back out to my team space. I'll go to my jobs tab, and I should be able to see my Docker job pending right here. So we know it ran from a container. So now we'll have all the logs of that Docker job as well, and all of the same benefits we had with the other methods, except for this time, we are actually using a container that we have sitting in a registry of our choice. And we can see that it's on that L40S as well. Now, the positive outcomes of a system like this is that you can send jobs, you can send parallel jobs, you can send jobs from containers that you own without having to know Kubernetes or interface with a DevOps team, which can cut down the time to run and complete your experiments significantly. This will end up allowing you to bring products to market more quickly, update your models more quickly, and overall improve the velocity at which you develop and use and implement AI in your business. Thanks so much for listening, and feel free to reach out if you have any questions.